Integration by substitution, example 1C. All right, now you'll notice one of the things I've already done from the original question to the board was to rewrite this. So just keep in mind that because of the radical there, that would be a 1/2 power, and it was brought upstairs, so 1/2 because of the radical, negative because it was brought upstairs. And then that's pretty much all you can do algebraically to that. So, I hope you're accustomed to doing that. And by the way, no, there is no quotient rule for integration. So we need to do things of this nature here. And there's no product rule either. There is a product here, but there's no product rule for integration. All right? Substitution is where it's at. So I would hope you would agree with me that the variable u would take the place of that quantity being raised to a power x minus 3. So u would equal x minus 3. And so on this new integral that we're going to run off with, that would change into u to the negative 1/2 power. All right? That portion of it would be u to the negative 1/2 power. It is important that we make sure to replace everything in the entire expression in the original question. So this is that part of it, u to the negative 1/2. All right. I would always tell people again that everything gets built from that original substitution. Build a dx. All right, so you differentiate both sides with respect to x, and du dx would equal 1 in this case. And we clear the fractions. And in this example, it turns out that du is equal to straight up dx. And so, yay, this has been accounted for. It has been replaced. And so the dx in the original question has been replaced with du. So far, very similar to the previous two examples. However, that's not everything in the original expression. There's also the 4x plus 5 sitting out here. All right, so what do we do there? We build it. That's the best way I can describe this. And I would always tell people that if there's other expressions floating around out there, you need to construct them from your original substitution. So here's how I would do this. I'm going to transfer this over here, u equals x minus 3, that's our original substitution, and I'm going to build that expression from this. So what I would suggest doing first is to build the x. Okay, so algebraic manipulation here. How about we add the 3 over and essentially solve this for x. We're being algebraically creative. All right? So, if you say that u equals x minus 3, that's the same thing as x equals u plus 3. Build the x. And then build outward from there. So the next thing I see in this original integral is that x is being multiplied by 4. So, let's multiply both sides of this. Let me give myself a little more room here. We're going to build a 4x from this. This is algebraic creativity here. So we'll multiply both sides by 4. And over here on the left, 4u plus 12 turns out to equal 4x. 4x. We're creating this expression that was in the original integral from the original substitution that we made. All right? So we're one step closer. Now what? Oh, we want plus 5. Okay. Plus 5. Plus 5. And so the expression 4x plus 5 that was in the original integral is equivalent to the expression 4u plus 17. Yay! All right. So, let's see, I'm trying to use shapes to make these things stand out. So let's put a blue triangle around that. Wasn't 4x plus 5 in the original integral going to be replaced with 4u plus 17 over here? 4u plus 17. Now you might say, well, wait a minute. What did we just accomplish there? It seems like this new integral is as equally complicated as the original, but in fact, it's going to have a different algebraic structure. All right? So once again, 4x plus 5 gets replaced with 4u plus 17. And you're like, well, what good is that? You told us a while back that there's no product rule, and we still have a product over here. Yeah, fair enough. But that's a different kind of product than the original one. We couldn't distribute these because this expression had a power on it. Anyway, hit pause if you need to. Take a moment, all right, take a deep breath. But I would say everything here got replaced. And I will also say everything got built, everything up here got built from this original substitution. You gotta think. People before you have done great with this. You guys are gonna do fine. Okay, so now, here's the deal though. The algebra structure of this new one is different than the other one. Because unlike that one, we can distribute this u to the negative a half into the parentheses. It's got a different algebraic structure. So, let's see. What do you do when you have u to the first times u to the negative a half? You add the powers. It's a 1 and minus a half. That's 4u to the half plus 17 u to the negative a half. And hopefully you would now go, oh look, that new integral is terms with powers. And we can do the power rule to each one of those terms. Yeah, so you couldn't distribute these, but you could over here. And that's the beauty of this new integral, is we can now apply the power rule to each term. Yes, we can integrate it. Yay! All right, so 4u add 1, right? This is a couple of assignments back. So if you add 1 to that, 1/2 plus 1 is 3/2. And then remember, instead of putting that over 3/2, n plus 1, n plus 1, instead of putting that over 3/2, we invert multiply and call it 2/3. We've done this, all right? Plus 17, u add 1, negative a half plus 1 is positive a half. And again, instead of putting that over a half, we invert multiply. That'll be times 2 over 1. And then remember the waitress plus c. I don't know if you can see that there, but it's there. All right, let's clean it up a little bit. 4 over 1, 8/3 u to the 3/2 plus 34 u to the 1/2 plus c. There you go. All right. Yeah, that's pretty complicated. But hey, what can I tell you? Almost done. One thing that's very easy to forget to do is after we run off with u, and the u is easier to integrate, right, is to go crawling back to our x and replace it back. So u is going to be changed into x minus 3 in these two places. And so there we go. This final answer, because look, the integral of a function involving x is going to be a function involving x. We're just using u to make the integration easier. Okay, it's got a different algebra structure than the original. So, substituting back, we have 8/3, expression x minus 3 to the 3/2. Everybody see what's happening here? This is going right here for here. Plus 34, expression x minus 3 to the 1/2 plus c. Bang. Wow. Whew. That is some really good, awesome restaurant quality calculus right there, my friends. All right. So, yeah, it's not easy. You can do it though. People before you have. Of course, they've had the advantage of being here so they could ask questions and stuff, but everybody's doing the best they can, right? That's all we can ask of each other at this time. So let's hang in there. Let's enjoy some more substitution.